Alrighty. So we're talking about polygons. Polygons, Polygons. Polygons. Right? Polygons mean multi-sides. So the first thing we want to do is name your polygons, because in a problem, if it says something about a heptagon or a septagon or a dodecagon, you need to know what they're talking about, right? How many sides do these polygons have? So here's some pretty general ones, right? A three-sided polygon is called a triangle. Pretty easy, right? Hopefully you know what a triangle is. Or maybe if you're not from this country, a trilateral, which means three sides. Triangle means three angles, so trilateral or triangle. Okay, in general, a four-sided figure is called a quadrilateral. A quadrilateral has four sides. Literally, lateral means sides. So four sides. Or, if you're from another country, maybe a quadrangle. Means four angles. Like we call it a triangle in America, three angles. You could call this a quadrangle, four angles. Right? We usually don't do that. It sounds strange, but it's perfectly geometrically correct to call a four-sided figure also a four-angled figure, a quadrangle. And a regular polygon is called a square. Okay, so we have this term called regular. Okay, a regular polygon. What does it mean to be regular?
Normal.
Normal is not regular. So a regular polygon is one that is the most perfect polygon, meaning it has all angles and all sides are equal. Okay, all angles and all sides are equal in a regular polygon, or are congruent. Right, that's our geometric word for equal, having the same measures. Oh, that's some sloppy handwriting. I haven't done this for a while. So regular means perfect. All the angles are the same, all the side lengths are the same, which is why a square has four equal angles and four equal sides. Regular polygon means a perfect polygon. Okay, five-sided figure.
Pentagon.
Pentagon. Right, penta is the, I think, Latin, maybe Greek or Roman word for five. If you're a track athlete, there's something called the pentathlon, which has five events in it, a pentathlon. So a pentagon is five gons or five sides. Six is a hexagon. Right, six sides, hexagon. Seven. Notice seven doesn't have a picture because it's not easy to draw. But if you'll notice, all the things with an odd number of sides have a pointy top and a flat bottom. Right? So we could draw it having 1, 2, 3, 4, pointy top 4, and then 5, 6, 7. Flat bottom is a heptagon or a septagon. Heptagon or a septagon. Okay, a little bit of history for you. Before the Roman Empire took over the known world in the whatever year that was, September was the 7th month of the year. September. Sept means 7. So September was the 7th month. And then Julius Caesar got a hold of it and put his month in there as July. And then Augustus Caesar got his name in there as August. And he squished September down to the 9th month. But it was originally the 7th month in the original calendar.
Wait, so if they never did that, we would...
Okay, eight-sided figure is called an octagon, right? So we have the month of October. That was the 8th month after the month of September. A nine-sided figure is called a nonagon, like the month of November was the 9th month originally. September 7, October 8, November 9, and what's the 10th month? December. not December. The decagon, right? Deca, it means 10. So the decagon was the 10-sided figure. December was the 10th month originally. Okay, so they're not anymore, right? They're 9, 10, 11, and 12, but they used to be 7, 8, 9, and 10 based upon their prefix. Okay, so the first thing I want you to do is learn about these words and what they mean as far as the geometry goes. Now, there are names for these other ones, but basically anything after number 10 is called an n-gon. So a 15-sided figure would be called a 15-gon. A 19-sided figure would be called a 19-gon. Okay, a 30-sided figure would be a 30-gon. Now, there are special names for them. But those ones aren't as important or as commonly used as the first 8 are. Okay, triangle through decagon. So we have some things here. How many triangles are formed by your diagonal? So can we draw a diagonal on any triangles? No, we can't. So there's one triangle here. And what is the interior angle sum of a triangle?
180.
180 what?
Degrees.
Right? All of these answers are in degrees. So a triangle has a 180 degree interior angle sum. Now, interior angle measure, this is for one single angle. One out of those 3 angles, 60 degrees. How do we figure out what any interior angle measure is? Take the sum and divide it by the number of, we're going to call them sides. But yes, angles and sides are the same, right? A triangle, 3 angles, is a trilateral, 3 sides. So the angles and sides are the same. So to find one angle, you take the sum and you divide it by the number of sides. Now, what about an exterior angle measure?
90.
If the interior is 60 degrees, so let's draw this real quick so we can figure out what an exterior angle is if we don't remember. So here's our regular triangle with a 60-degree angle. Remember, the exterior angle is the one out here that is formed when you draw a extended one of those sides. Okay, so what's the relationship between an interior and an exterior angle?
120.
Well, they add up to 180, right? They are supplementary. They form a linear pair. Right? All of these vocabulary words from first semester. So because they add up to 180, that has to be a 120-degree angle, right? So every exterior and interior angle add up to 180. They are supplementary. So if my interior is 60, my exterior is 120. Now, how many exterior angles are there? 3 of them. So if they're all 120, they add up to 360 degrees. Okay, so we're going to do a similar thing for the rest of these, well, for a couple of them, and then we're just going to go in and talk about the formulas. Okay, so when we're talking about diagonals, where does a diagonal go?
Across.
From one corner to another corner, okay? And once you draw it, that is the diagonal. So there is one diagonal. How many triangles do we see? 2 triangles, right? The upper left and the lower right. Only 2 triangles formed by a diagonal. So if there's 2 triangles and they each have a 180 angle sum, a 4-sided figure has a 360-degree angle sum. And for a regular polygon, 360 divided by 4 is 90 degrees. I think about a square. A square has every angle of 90 degrees. If your inside angle is 90, what's your outside angle?
90 also.
90. And there are 4 exterior angles. 4 times 90 is 360. Right, we're trying to establish some patterns. So if I draw in my diagonal, I have from the same vertex, how many diagonals? 2 diagonals. How many triangles do we see? 1, 2, 3 triangles. 1, 2, 3 triangles in a 5-sided figure. So 3 times 180 is? Excellent math skills, 540. So all the angles add up to 540 for a pentagon.
120.
And if you divide that by 5, right, what's 540 divided by 5, the number of sides?
Oh, really? Oh, wait.
108, right? 40 divided by 5 is 8, and 5 divided by 5 is 1. So 108 degrees for an interior angle measure of a pentagon. And the exterior angle measure is 72, because 180 minus 108 is 72. Now if we times that by 5, we get 360. Do we see a pattern for the exterior angle sum?
It's 360.
It's always going to be 360 degrees. So the exterior angle sum will always be 360 for any polygon. They will always add up to 360. Okay, so we're going to pause the video and fill in the rest of this chart so that we can get down to the bottom where your formulas come into play. Okay, so on the bottom is the important stuff, the formulas. Okay, so there are always 2 less triangles than there are number of sides. So n stands for the number of sides, right? That's the important part about this whole entire polygon thing. So to find the interior sum, you take the number of triangles, which is n minus 2, and you times it by 180. And that tells you all of them added together. Okay, if you want to find one of them, we take that sum and divide it by how many there are. So the interior angle sum divided by the number of sides tells you one angle, right? One interior angle. And since all the exteriors add up to 360, if you take 360 and divide it by the number of sides, that gives you the exterior angle measure. Okay, so these formulas are the important thing to get out of this, besides the vocabulary. Okay, so let's flip the paper over and look at some geometry problems that we're going to use in order to, well, we're going to use these formulas. So I'll write them on the board so we can look at them and you can use them to solve stuff. Okay, number 1, determine the sum of the measures of the interior angles of a 20gon. Okay, so how many sides does this have? 20 sides. So the interior angle sum, that would be 20 minus 2 times
18 times 180.
180. So 18 times 180, 3,240 degrees. Okay, so all of the angles will have a degree for them. There's 2 units, one of them is degrees, the other one is number of sides. Okay, find the sum of the exterior angles of a heptagon. How many sides does a heptagon have? 7 sides. And the sum of the exterior angles is 360. No calculations needed. As long as you remember that the exterior angles add up to 360. Okay, find the measure of each interior angle. Each interior angle of a regular pentagon. So we need to know the sum of a pentagon and divide it by the number of sides.
108.
So a pentagon, right, how many sides does a pentagon have? 5. So 5 minus 2 is 3. 3 times 180 divided by 5. So 3 times 180 is 540. That's the sum of a pentagon. 540 divided by 5 is 108. Yes, I believe we did that on the other side for your chart, but being able to calculate it is better than memorizing. Okay, you don't need to memorize when you can calculate. Find the measure of an exterior angle of an octagon. How many sides does an octagon have? 8 sides. So exterior angle, 360 divided by 8. 360 over 8. Calculator says 45 degrees. 360 over 8. Okay, number 5. How many sides does a regular polygon have if each interior angle measure is 156? Okay, so there's a couple ways that we can do this, right? We know the interior angle measure is 156. So 156 equals n minus 2 times 180 over n. Since we don't know what the number of sides are, we have to solve that equation. Now, are you pretty good at your algebra? Right? Are you confident in being able to solve this for n? Right? Maybe not. So let's think about another way potentially. If we know the interior angle measure, what else do we know? The exterior angle measure. If the interior is 156, then the exterior angle is 24. Right? What's 180 minus 156? Is that 24? Okay, so the exterior and the interior add to 180. So if we know the interior, we subtract it from 180 to get the exterior. Okay, so we know that the exterior angle is always 360 divided by the number of sides. Right? That's how we can calculate the exterior angle, is by 360 divided by the number of sides. That must mean that the number of sides is equal to 360 divided by the exterior angle. Okay, that's probably the easiest way to calculate the number of sides. Okay, so the number of sides is equal to 360 divided by the exterior angle measure. Okay, that's one that we're not going to put on the charts, but that's something that you should probably learn, because it will come up a couple of times, and it's a lot easier to calculate the number of sides if you know the exterior angle than if you know the interior. Okay, so the number of sides is always 360 divided by the exterior angle measure. So 360 over 24 is 15. So this polygon has 15 sides. Right, so here the units are sides, not degrees, because we're not talking about an angle. We're talking about the number of sides. 15 sides, okay? That's a pretty important problem. That's some algebra, some extended thinking right there. Number 6, if 8 angles of a nonagon total 1200, find the 9th angle. Okay, so the question is, what do all of the angles of a nonagon add up to?
1260.
Okay, what is the sum of a nonagon? What do all 9 of the angles of a nonagon add up to? So that's 7, right? N minus 2 times 180. 7 times 180 is 1260 degrees. So that's all of them, right? All 9 angles have to add up to 1260. 8 of them add up to 1200. So what's the measure of the last one? 60 degrees. Okay, so notice it doesn't say a regular polygon, right? So if it doesn't say regular, do not assume that all of the angles are equal. Only if it says regular are all of the angles and all of the sides equal. Okay? So I think you can do the rest of these. So we'll pause and then you work on them and then we'll come back in a sec.